Yeah, but then, as well, the same applies to any other field. How will you know you've done an error? Because you rely on the technology. If a computer gives you a mean of 3.5, how will you know it's right or wrong? Just use that. But with that, yeah, true. And I guess it's the same with accounting. Because when I learned accounting, you had to learn the gap, the way, the foundation, the traditional way of thinking accounting.
I never mastered it.
Last in, first out, first in, first out. Now,
That's logistical.
yeah, but still, in actual accounting or in business now, the last in, first out, what? First in, first out.
LIFO.
Yeah, fair for LIFO. One is useless, one is not used.
Not always. It depends on what it is.
Not in accounting.
Well,
Ideally, you have to always
it
send
depends
off
on,
things that came first.
No, it depends on which industry you're in.
that's what I'm saying.
It's like if you're in the petroleum industry, regardless of even though you've already gotten
Okay, no,
let's
that-
say,
okay.
inventory, what's the price? You'll be using the current price instead of the previous price. That's
No.
how it is.
That's because petrol is what adds on to the previous one. It still doesn't change.
No, it changed because they have to finish up the other one before they put in the new petrol.
Because the price in the books, it reflects on the historical cost. Yeah, but then the actual commodity, you can't then I hear you. But yeah, I hear you. Anyway, this story is the same with stealth. You see, part of these things I'm going to take you through is just a bit of, okay, we're not going to ask you the actual calculation in the color, in stealth, but I'm still going to ask you to calculate with using Excel, with the data you have. I kept it brief. For the lecture today, I just kept it brief because I'm more interested in the interpretation more than anything, because that's where it kicks people and the understanding of why things are. Anyway, with the data you have, now there's something called descriptive statistics. Descriptive statistics are those first found. That's it. When you measure mean, the mode, the median, all those things, they don't give you, they just describe the data as is, nothing else. Now, that's the problem why if a research or a study only has mean, the mode, the range, whatever, it's not enough to infer, to draw conclusions. Anyway, with the data you have in front of you, please calculate the mean for what is the first column. What is it? Sales.
So, yeah.
Please calculate the mean. The function is average. And possibly write it below the column. Just skip 2 cells and then write them. Please label as well. Mean, mode, all of them. Below the column, below the last entry, define the mean. Just below the last entry, mean. I was surprised when I was helping some master student the other day. She did not even know what mean means, or average. Is it ever possible for someone to do M and still not know mean?
Very possible.
Well, they should have done it in
Somehow, somewhere,
research methodology.
And you see the culture we have of cramming that and going through and with that.
No, the second methodology is
Still,
no, we have
mean.
we do it when we do the second methodology.
Yeah. You're supposed to do it.
No, you
It's
do
not.
it. In our course, we do it.
In your course it's done, but in most courses it's not done because even the lecturer jumps.
And then jumps and then it doesn't come to bite you in the exams or something?
Even
Or
if
it's
it's not going to be
because you were never taught. Huh.
that when you do the research you deal with it when you're doing
You see, understand one thing. almost everything instead, almost, is based on the mean. Almost everything, because everything centers around the average behavior of the data set. Because ideally it captures what the centrality of the data. The function? No, you still need to calculate. Okay. Ideally, there is a function to calculate.
That's what I say. I don't know the function.
Okay, go to where they supposed to be. Below. Just one more. Yeah.
Wow.
Then calculate equals to the mean. Equals to mean. Yeah. No. Mean, MIN.
Well, minimum.
Minimum. Yeah. That's it. Open bracket.
Okay.
There we go, and then you
And
select the
just
range.
select
The range, the whole entire range. Yeah. If possible, skip a line between sum and the last entry. Just insert here.
This is I'm also on the new.
Okay, right click, yes, insert. There we go. So then, please keep cell behind, just below.
I'm very much left behind in this thing.
Mhm.
I think, no. I meant everything.
Mm.
I was not attending for some.
Don't worry, let's catch up. Let's catch up now, yeah. Okay. Try and, first thing, what is this? Click on it, let's see. Okay. Pull it down, just, yeah, pull it down. Not like that. Okay, clear, pull it down like that. Oh, go down. No, okay, let me help you. This thing needs to change to this. See, this is a square kind of class. It changes to this, then you pull it down, it's fine. Please label that. This is mean, mode, mean, range, whatever. Start with the labels first. Just like those.
Just like.
Yeah, mean, mode, range, mean, max, and then the mode, and then the median. We're gonna also please add the median as well. That's average. That's mean. Type the mean. Type the actual weight. Mean, MEN. Okay, enter. And then type the mode. Yeah, mode. Why are you copying? Type all the names. Type all the names. Mode, range, mean. No, don't copy. You can't copy in master's level. You can't copy. Yeah. Okay. Type the mode. And then below range, and then below mean. No, don't yet calculate the thing. Don't calculate. Yeah. And type the range. Yeah. Range. You know, mean, max.
What else?
Yeah, mean, max.
Mean, max.
Yeah, and then median.
Median.
Please add the median one as well.
Mode is the one that is
Okay.
most common. Eh?
Yes, but also the same function, equals mode.
Okay, but and then you select them.
Yeah, and then you selected them again. I'll talk about all those
Now,
and the interpretation. Enter.
says it's not applicable.
Why?
I don't know.
Why? If there's no mode, you should say the 0 or something. Calculate. Other ones. Calculate. I need answers for the whole distance. Hey, I'm wondering now if we're gonna get to the second part. Please open the. Hey, let's see. I don't think this one works. Does it work? I don't think so. Please sit somewhere else or somewhere or here or there. Or you can be here. Or whichever. But try not to be far away.
You're not going to put me on my jokes.
No, that's one I want. Okay. Thank you. I cancel that thing. Cancel. Click. 1, 2, 3. That's a good thing. You came on the right of all this. Click.
My computer.
My computer. and then removable. Removable. And then enter. Yeah, they both come out properly. There is mode, and they have a range, and then mean, and then unmode. Then, if you do know how to calculate, please calculate it.
So you should calculate now.
Yes, please.
All right.
No, I wanted you to type it. How far you know? No, okay, it's fine. Let it go to the range and calculate the range.
I just put the range. Those two.
Yes, it's the difference of those two.
Yeah.
Yeah, you can do it like that. Or you can do it the long way and put the formula of the first one minus the formula of the second one, enter. I'm saying you can do it the long way, enter the max and then difference of the mean. Don't worry, you will find a way to save this. Please now calculate. First thing we need to do is try and calculate now. Here, equals 10 equals average. Type the average. Average. Open bracket.
Space.
Yeah, oh no, not space, open bracket. Yes, then you select this whole list.
This one.
Yeah, no, from here, and then click and drag. Yes, like that. Go up, go up, go up, go up. Yeah, okay. Stop here, go down a bit. Yes, enter and end. Okay, say enter or close bracket, whichever. There we go. Then that's the mean, and then we need to calculate for mode equals to mode. You do the same thing. Equals to range, you do the same thing.
Equals close bracket.
No,
average.
no, you don't do that. No, you don't do that. Average is for the mean, only mean. There you open mode. You type the mode, MODN.
Open bracket.
No, you not. I did not do this. Mean, mode, range, mean, max, median. Okay. The mean, what is the mean that you got?
4,5,7,2,7,4,6,3,5,6.
And then what does the mean? What does the mean mean? What is the mean? What is the interpretation of the mean? Yeah, but what does average mean? See?
Okay, you add all the amounts and you divide by the number of entries.
You what? You add numbers divided by the number of entries.
If there are 10 entries, you add the whole numbers by 10. That's your average.
Okay. You see, ideally, what it means is that when you look at all the data from the central number, that's the average. The reason why we usually need to calculate average is because that's usually where most of the data lies. So average is usually where most of the data lies. So therefore, it plays a significant role in understanding the data. Now, the only disadvantage with the mean is that if you were to plug in the, let's say for argument's sake, if you look at the sales, they are between, okay, I need to calculate the range. What is the minimum number for sales? Excuse me?
3.778.
It means on a bad year, the sales amounted to 3.778. Yeah, 3.78. almost. Now, on a bad year, sales were 3.78 units. It doesn't matter if it's millions, billions, whatever. The units, you keep the same. Now, on a good year, what was the maximum? On a good year.
95.4 the other way.
Now, on a good year, 90, you sold so much unit. Now, the idea is that with average, between the two extremes, most of the data lies around 45.72. That just says between the two extremes. It gives you an indication of how you fared on average when you put all those things together. Remember, when you add just those two, 3 point something plus that 90, 95, the average, when you add the minimum and the maximum, usually it's almost or close to the average. You can test this. Add the minimum plus the maximum divide by 2. You'll get a number close to average. Can you please try that? What is the average of the two numbers, two extremes? 3.77 plus 95.41. What is the average? What is the average of those two? Add those two, divide by 2. 51.48. 3 plus 95 should be 48 or something. 90. 98.29. Yes. No, 99. Should be less than 50.
The average is 49.59.
Yes.
49.59.
Yes.
I didn't put the brackets.
They see now it's gonna just take the half of whatever is on the other side. Now the idea is that on average things are in that range. Now later on we are going to talk about confidence level. Now the point is you should get a picture of what's happening. Now the interpretation is the most important thing. You know that on a good year, whatever this business is, sales amounted to 95 point something. On a bad year, it amounted to almost 0, 3 point something. Now, on average, you are looking at 45 to 50 in that range. Now, the range in this case takes the difference of those two extremes. It just covers all the data. That's what the range does. Now, the range in our case, oh, you can't see this. The range in our case is 91.62. It just means all the numbers lie in the region of 91. The difference between the highest and the minimum. Now, all the 91 covers all the numbers. Remember, range doesn't tell you what is low, what is high. Remember, you can calculate, you can also end up with a range of 91 if the numbers were from 100 to almost 200, or 105 to 200. Now, still, you're going to get that range. It doesn't tell you what was low, what was high. It just tells you the distance the sales covered. That's it. That's it. Now, please calculate quickly for the other two columns. You can just quickly drag the formulas. For the other two columns, pressure and something. Temperature and pressure. Is it pressure? Yes, temperature and pressure. What is the mean for pressure? What is the mean for temperature? 5.16 and 11.16. The same interpretation applies to the mean, but you always relate it to the units that you are looking at. Remember, the mean is always based on the actual units the data is in. If the unit is in kilopascals, that's what the mean would be. temperature is in degrees Kelvin or it's in Kelvin, that's what the unit is going to be. Now, please note, the mode is just the number that occurs the most. The reason why our mode doesn't exist in this case, Excel format, is because there is no mode. The number that occurs more than once in this case. Are you with me? You can't get.
For both
Okay,
attempts.
click on it. Click, yeah. Okay, let me help you. Here, you say equals.
Equals.
The maximum. This click with this.
Why do I click on the
The
maximum?
maximum and the number. The number. No, click on the number. This
Okay.
click minus
Minus
the minimum.
minimum.
The number here. The minimum. The minimum number. Yeah. Yeah. Enter. That's what the range is. It gives you the difference between what was high and what was low. That's what the range is.
All right.
Mm.
Okay. Yeah, I do the same.
You do the same thing.
I say equals. And
Okay, just rather do this. Let me help you. Do the backspace. You can take everything like this. Then you click and drag. It automatically applies the formula you applied previously.
I guess
Yes.
for practical purposes, you need to do.
Yes, you
Because
need.
I
Yes,
didn't get it right
yes,
the first
I
time
hear you.
around.
Yes, I hear you.
Marvel,
Yes,
what is the median?
the median.
Yeah. That is the figure that is in the center of
The data set.
yes.
Yes, on one condition. The median is the number the number in the center of the data set after the data set has been sorted. Ascending or descending, doesn't really matter. It will still be in the middle. Now, it's only based after you have sorted the data. Now, in this case, you cannot calculate the median as is because it's unsorted.
Although,
When the function itself first sorts, yes.
but what I've done, I have taken the data set and then I said equals median and then I
Mm.
took the data set.
Yes?
But then the figure that it gives to me
Mm.
doesn't appear in the data set.
Yes, that's true.
But shouldn't it be that figure there?
No, it should. That thing should be there. Now, see, the same applies with the median, with the mean. You can get a number that doesn't appear in the data set. Now, I like your question because of two things I really missed on my lecture. Okay. Okay. Now, there is something called, on quantitative statistics, there is something called continuous data and discrete data. Yeah, discrete and continuous. Now, if you are going to calculate a mean on something that is continuous, you will get, it's possible to get a number that is not in the data set. But whereas for, okay, the mean, you can also get it in continuous for something that's not in the data set. But the median, it's impossible to get it on something that's discrete. Now remember discrete, can I show you an example of discrete? Quickly. Do you know what discrete means in the first place? The concept, this is what it is. What? Okay, now please quickly stop working and stop Facebook. Okay, now, remember now, in any phenomena, you can get characteristics. That's what we call variables. Now, some variables, you can only get discrete data. Now, for instance, the question is, how many siblings do you have? You can only get 1, 0, 3, 4, whatever the case may be. Now, that number that you are going to get is discrete. Let's do a test. How many siblings do you have? Quickly. 3. How many siblings do you have?
1.5.
Oh, what happened to my information now?
1.5.
There we go. 3. Number lock. Number lock. Okay, 3. What's happening to my computer? Something is wrong with my computer. It doesn't want to use 3. Okay. 3. Number of siblings? 4. Number of siblings?
1.5.
There's no such. Number of siblings? 6. Number of siblings? 3. Okay, 3. There's one on the way. Now, this is the story. Okay, now, let's quickly notice. I'm going to calculate the median. Now, median equals to average. Select, enter. 3.8. Is it possible to get a mean number of siblings as 3.8? Is it possible? It doesn't have interpretation. You with me? You with me? Yeah. It doesn't have interpretation. Understand, this is on number of siblings. So it's impossible to have 1.5, 3.8 kids. Oh, yeah. Now, what does mean mean in this case? What does mean mean? What is the interpretation? What does it mean? What is the idea behind mean?
Most families have almost 4.
On average.
Yes, you with me? Now, it depends on how many people you're asking, what are the inputs, the numbers that you got. Because it's just summing everything divided by the number. That's what mean does. Now, almost. Now, because we are looking with people, we have to say almost 4. Because people. Now, with median, equals to median. It's just going to take the number that's in the most, in the middle. Now, okay, it's a coincidence. We have 5. Let's add one more. Let's give me any. Come on, how many siblings do you have?
6.
Excuse me? 4. Okay. Yeah. Okay. Now, this is the story now. Median. It looks at the number of data and then divides it by half, directly by half. Now, whenever you have odd number of numbers, odd number, 1, 3, 5, 7, whatever, you always have a complete median. Whenever you have even number, it's going to take the 2 and then divide by 2. Now, ideally, it still gives you, okay, the idea is to divide the data into 50%. There is a part we'll do percentiles later on. Then I'll explain as well. You'll relate the mean to it. To get the data set in sorted format, divided by half. Now, in case the number of numbers, the sample size now, n, is even, it's going to take the 2 numbers that are in between, divide by 2. Now, in this case, it's 4 and 3. The 2 numbers, so the median is 3.5. Now, interpretation. 50% of the numbers are lower than 3.5 and 50% of the numbers are higher than 3.5. That's only what it means. That's it. That's it. There is a part we're going to do later on with percentiles. The same thing. Now, it will just divide into percentages. You know there are only 100%, right? There is 0 to 100 and 1 to 100. So it divides the data set in 100 portions. And then you specify which portion you are looking for. And then it gives you the result. Don't worry, we'll do it later on. Now, anyway, the point is with discrete data, you cannot have anything that's point because it does not have interpretation. So therefore, in any instance, you should always have full numbers because you can only explain full numbers for things like that. Now, I put another thing. The same applies to population. You cannot have 0.5 people, even if the person is a child or whatever the case may be. The same with the color blue. You can't have half of blue. How many colors are blue? 1, 2, 3, 4, 5. It's just discrete. The same with jeans. Even if your jean is torn in half, it's still a pair of jeans. Or it doesn't, you don't count it or you count it. That's it. That's what discrete means. Now, anything else that is not discrete is called continuous. For instance, time. You can have time in hours, and you can partition hours into minutes. You can partition minutes into seconds. You can partition seconds to milliseconds. Partition seconds to nanoseconds. You get 0.0.0.0. That's what it means. As soon as a data set has comma, it becomes continuous. Now this is the story. This is the thing that kicks a lot of people. People just calculate mean. You can't have interpretation. Not everything has interpretation. 3.5 people doesn't exist. So therefore, it cannot be done. That's why this is part of the thing that we're referring to as biographical in most research. You don't calculate means. You just calculate percentages. Or you calculate, where is my mode? You calculate modes. Modes, you just calculate modes. How many people were females? How many people were males? Modes just calculate the frequency. That's it. Your interpretation is going to be on mode. So many people responded to my questionnaire. They were males. It ends there. You can calculate percentage. That's possible. 20% were males. Still same thing as mode, as frequency. Now, that's the first part of the, we have a long way to go. Okay. Can we speed up the process? Dispersion. We need to calculate the variance, the standard deviation, and then we're going to do the percentiles and quantiles. Just in your data set as well, underneath the median, your last entry. Your last entry, underneath there, please put there's variance and standard deviation, percentiles and quantiles. Am I audible? The variance is called, in Excel, it's equal var, V-A-R. Equal var, you get variance. Yes, STDED, EV, yeah, standard dev. Are you winning? Who has problems? Are you done? So what's wrong? Excuse me? Equals STD? Yeah, there it is. You see, you can also estimate standard deviation based on sample. That's what we know. You need to EV first. EV,
Okay.
EV, open bracket. All the numbers, yeah. What are you looking for? Percentiles. You put it here. Cancel. Yeah. Then equal, put it here. Yeah. Yeah. Equals to percentile. For that's PE. Start typing the almost just like the way it is written. Type, you'll see. You'll eventually see the way as well. PE. No, not C. P. P. E. No, just start typing first. Don't look for it. There it is. You can double click. Then open. Yeah. Okay. Then select everything. Now this is the kicker. I have you done standard deviation first, but you have jumped the queue though, and it's fine. Have you calculated the standard deviation? Can we try and go to the percentile first before we go to the standard deviation, or before I address the standard deviation? Percentile equals to percentile. It will give you an error if you don't know. I'll explain. Just go to fine. Wait first. Wait at that formula. Equals to PER. You will see the weight though. Just type the full name. Otherwise, open bracket. Yeah. Then select everything, and then write comma. Thing is, it will kick out because it needs to be specified. Yeah, same thing with quantiles, because quantiles and percentiles. Now, No, listen. For the percentile, it divides the data into 100%. Now we need to specify what percentage do we need. Remember, median measures 50%. You may not want 50%. Percentile gives you the leverage to change to whatever number. Let's say, for argument's sake, 67. 0.67. Remember, percentiles are numbered 0, 0 comma something. Percentages is 0 comma something. So 0.67 and then enter. Percentile, after you type in percentile equals, you open the bracket, then you select everything, and then you have to type comma 0.67 equals. Come here, do this. Yeah, equals PE, yeah, type the whole thing. Yeah, open bracket, select everything, then comma 0.67. 0. Okay, number lock, right there again. 0.
Do I have to delete this?
Yeah, no, delete this. Comma, you can now type 0, comma, 67. Enter. There we go. What is the number? What is the number for 67th percentile?
5.
Excuse me? 5.044. 55.044. That means 6. Yeah, okay. Please listen. Please listen quickly. Percentile. The interpretation is the same with quantiles, but I'll explain now. Equals to percentile. Here's what I want. This is the range. What number did we use? 67. Okay, it's 5.55. Yeah. Now it applies the same philosophy as the mean. After the data has been ordered in ascending or descending, 67% of the data is below 55.04. That's what it means. It means sales 67% of the sales are below 55 point whatever units. That's what it means. Capish? Now, the same applies with quantiles. Quantiles, there are 4 quantiles only. Remember, percentiles, there are 100. Quantiles, there are 4. There is the first quantile, which is 25%, the second quantile, which is 50%, which is equal to the median, and then 75% is equal to percentile 0.75, and then the other one, which is 100. But mainly we look at the 3, 25%, 50%, and the 75, because 100 is automatic.
So should we do for all of them?
No, just do, just do for the 2, the 0.25 and the 0.75 for the quantiles. Just do the 2 quantiles. And then I'm more interested, actually, the second quantile, so that then we can make sure it's equal to the mean. And then we also do percentile 50, just to see. We're going to have to do 3 things. Quartile 0.75, quartile 0.5, percentile 0.75 or 0.5. Yeah.
I want to catch it. Thanks. I'm going to session. We're sorry for.
That's fine. It's fine.
Okay.
It's understandable.
Okay.
Sure. Which one is not available? 0.25 for what? Okay, I'll be with you. Okay, what are you doing? For the quartiles, you just put the number. There is quartile 1, quartile 2, quartile 3, quartile 4. That's it. Okay, go down. Go down, scroll down. Don't include this data, okay? Start here. This is the data. So send, yes.
Oh,
Okay, wait, it's fine. Delete, let's start afresh. Okay, this is where you are, right? Right there, comma 2.
comma
2.
0.
No, not 0 point, just 2. Yes. Enter. Equals quarter, yes. Okay. C to 42. That's because it adds this now. Yeah, that's correct. So it's because, let's come here. It's because the data, okay, it includes this NA. Okay, let's start here and then go up. You will see it works. Enter. Enter is fine. There. The point was, it was doing for this number. You can do it for the same with the other one. Okay, you can redo this. Let me delete it. Redo this, but you don't include this one. Start here. Equals quartile. Comma. Comma 2. No, not that. This is not a comma. This is a comma. Comma 2. Yeah. 2. Enter. There we go. Are you winning? What? Yeah.
That needed research methodology. We had to work these with
Is it?
by hand.
By hand. Ha! Welcome to the world of technology. No more hand. No more. see,
It makes us lazy.
most of the time, the quantiles, the percentile, they tell you the distribution of the data. Now, it's always important to know that before you start modeling, because this is the first thing we do in statistics. We need to know the skewness. This also will tell you the skewness of the data. Before you model anything, you need to know how is the data behaving? Is it going down? Does it have tails? We call it tails. Now, those are the things we need to work out before you model anything. Now, it's important to understand the data. Now, this is one way for you to first get the first glimpse of how the data looks like. Whenever the mean is less than the mode, we know the median, we know that this data is skewed to the left. Whenever the median is more than the mean, we know the data is skewed to the right. Now, those are things we need to know. So then it helps with the analysis, because we know, okay, the data is skewed already. If the two are equal, we call it asymmetric. If the mean and the mean average, asymmetric. Anyway, questions so far? Yeah, I wanted to compare the mean and the median. The median, did you calculate the 50th percentile? What did you get?
48.128.
Quartile 2? I did only for quartile 2. So quartile 2, 50th percentile, and the median, they all are equal because they all refer to the same characteristic in the data. 50%. My man, can you turn the other way? I don't know. The other way? I don't know the other way. Yeah, that's better. Or the other way. I don't know how you're going to manage. I suggest then you sit the other side, so then you can turn right. Yes, okay. Questions so far before we proceed to the next part? Questions?
Sorry,
Yeah.
You said if the median
And the mean.
those are the two that you compare.
Yes, those are the two you compare.
So
To know the
the mean is now less than the median, so your data is skewed to the left.
mean is less than the median.
Yes.
Skew to the left.
Yes.
Yes. Yes.
Because you have to take the median as the.
Yes, 50%. Yes.
Thank you.
Skew to the left. The mean gives you the direction
Yes.
compared to the median. Yes.
In comparison.
Yes, to the mid. Yes.
Thank you.
Anyway, actually, there is also a way to do that. There is a function called KURTOSIS, kurtosis, skewness. It measures the skewness of the data. It's also a function in Excel. I think you. Okay. Do you want us to calculate it now?
No, it's not.
Okay. I was saying now, can you quickly go through the variance and the standard deviation, because also those are the most important things as well. The standard deviation, what did you get as the standard deviation for sales? The standard deviation?
29.8.
29.8. 80028 for the variance. For the standard deviation is 2 what?
298.80028.
Okay, what about the variance?
Variance 888.
888.
Yes. 0.058.
888. Yes. There is a relationship. I know you know this. There is a relationship between the variance and the standard deviation. One is the square, one is the square root. Right? The standard deviation is the square root of the variance, and the variance is the square is a square of the standard deviation. Now, the idea is with standard deviation, it tells you the volatility in everyday use. You know, the average just tells you the centrality of the data. Now, the standard deviation tells you, okay, volatility means when something moves away. What is the other word for volatile? Something's volatile. Something is volatile. Flexible is not the right word, but it has some, yeah. Yes, that thing. Now, remember, now, this thing is based on the volatility of the standard deviation is based on the mean. Please understand that every day. Whenever we're referring to the standard deviation, the differences or whatever, okay, now let me relate it to this. The standard deviation is 29.80. It means, ideally, each data point is far away from the mean by that much. That's what it means. This point you compare to this, the difference between this is 0 point something. The difference between this and this is 0 point whatever. This and this is, now, when you compare all those deviations, the average of the deviations amount to this. That's what it means. That's the thing. You see, yearly, the sales fluctuate by this much. From the average. Okay. Yearly. Okay. Sometimes you can get, remember this is, for argument's sake, this is yearly sales. On year X, sales were 44. On year Y, or X plus 1, 69. On year whatever, 5.
So
now,
you would like to get it as close as possible to the same, or
no.
deviation as little as possible for better planning. What you're trying to...
No, you want to see, you can't, okay, this is from planning point of view, you would say, okay, fine. We know that our sales mean, the mean is 45 point whatever. On any given year, we expect the mean. Remember, that's what mean means. We expect 45 whatever sales for whatever year. Now, we have to know that even though we expect this much, it can deviate by this much. So ideally, we are looking at 45 minus this plus 45 plus this. That range will be covered. For planning, then, that's what you're looking at. Because it can go down or up. That's also the next part. You must make provision. Now, that's how different things or yearly sales change from the mean. Now, it gives you understanding of how much what is our performance? How do we really perform as compared to the past? How do we perform? We always deviate from the mean by 29. Now, this is the next concept that I really will be touching on now. Statistical significance. Now, this is a concept that people need to understand, especially from a research point of view. There's something called statistical significance. This you set at the beginning of your study. Because the problem is, if you do not do that, you will force your results to abide by your statistical significance. For instance, the common alpha that is set in almost 90 point whatever percent of the studies is 95%. What it means is you want to be 95% precise on all your analysis. your conclusions are 95% correct. Now, it has to be set from the word go that you will do your study on 95% significance level. It means all your mean tests, all the tests that you will run, they are going to be based on 95%. And then you are going to evaluate based on the results you get on the 95 to conclude or to reject or to accept. Now, then there's something called confidence level now. Confidence level says you get your results based on your statistical significance. For instance, let's just say for argument's sake, our mean is 45.72. We know that it deviates by 29. Now, question if you want to do a test, say, what is the probability that the mean, your sales for next year will be 60%? Now remember now, it's not 60%, 60 units, whatever the units are. Now it's 60, you are saying you are going to get more than the mean now. Now, when you do that test, you will compare to the mean. Now, the question is at what percentage? That's where the 95% kicks in. You will reject or accept these numbers that you will get at that 95%. Now, the confidence interval is based on the number you are getting. The number you are getting was based on you testing at 95% with the hypothesis that the sales will be 60. That's what it means. Confidence interval is on the numbers. Significance is on the error rate that you are willing to accept, which is the 95%, which you define at the beginning. Are you with me? Now, this is where the thing comes in. Some people, because the data does not, or you reject the hypothesis at 90%, now they change the significance level to 90, so that then they accept things, which is a bad way, because now you are saying, you are cooking the books. In essence, you want the result to suit your needs now. It's no longer research. That's the point. That's the point. Yes?
Isn't that difficult? Because remember, you were just proposing, you don't really know what you're going to find at the end of the tunnel.
Yeah, but that's the point. You should propose and stick to it. It shouldn't change. Because if it changes, then now you're forcing things. You're forcing results. Remember, anything you can cook. Say, for example, if I stand to be corrected, in academia, in social science, the significance level is 80%. In science, the significance level is 99. No, actually 95. In engineering, it's 99. You see, it differs. Now, you have to stick to it, regardless of what, regardless. So therefore, then all your conclusions, you know everything is set at that 95, 99, or 80%. It shouldn't be, because now, say you are a social scientist, your thing is only significant at 78. Now you are forcing to accept it at 75, so that then you accept. That is the problem. That's why this thing is important. Yes?
So now, say for example, I'm using a 95%.
Yes.
And then my result gets to an 85%.
Yes.
Now, do I then qualify to say, in general terms, I can accept this?
No. You're supposed to reject, because you started off with 95%. And that is a conclusion. By the way, don't forget, that's a result.
My problem is we're not expert in this field. So we don't know.
What do you mean? What do you mean?
You just mentioned for social sciences. The general acceptance.
Okay, that's I'm from NMMU, so
Yeah, that's 80.
Yeah, some
Let's
yes,
say 80%.
yes.
Now, will it be safe then to say, let's just use 80% from the social sciences point of view? Because now if you use 95%, what happens?
I like that. If you, at the beginning, you set your bar at 80%, all your answers will be based at 80%. Don't change it. That's what it means. Because whenever you do tests, type 1 is the true negative of the question. Type 2 is the non-negative. the other way around. Are you with me? It depends on how the hypothesis is set out. But still, the principle is still the same. Type 1 is this, type 2 is this. I was thinking we should try and calculate some. Yes, actually, let's go to the data set. Let's try and calculate some confidence interval. Okay, let's put there 3 significance levels. (95% is 0.05). Okay, let's do this 95%. 90. 60%. Yes. Please note, before I come here. Now, this is the statistical significance that you said at the beginning, right? Now, alpha is going to be 1 minus beta. Alpha is going to be 1 minus beta. So, here, we want to be 95% correct. So the probability of making an error is alpha. Therefore, becomes 1 minus 95%. It gives us the 0.05. Are you with me? Can you see this? Okay. Therefore, what is alpha for 90%? 0.1. Thank you. 60%? Yes, now, sample size. Do you know what the sample size is? You know what the sample size is? You know what the sample size is? What is it? Okay, thank you. What is the sample size for the sales data? Give me the number. You can calculate. The sample size for the sales data, this data, the one we are working with. Excuse me? Yes, count would suffice. Equals to count.
84.
Did you get 34?
Yes.
Did you get 34? Okay, now, let's try and calculate the confidence interval now for the mean. For the mean, let's calculate the confidence interval for the mean. Are you with us, Nati? Okay, good luck. You have the sample size. Please have this. I want you to have this. Then we're going to get the numbers on the other side. Confidence interval now. When alpha is 0.05. Now, check it equals to confidence. In Excel, confidence, the word confidence, you will get it there. Did you get that? Are we in the same page? Do you have the confidence? Now, it says the first parameter is alpha. Our alpha is the one next to it, right? The 0.05. Click on it, and then comma. Then it will ask you for the standard deviation, right? Go to the standard deviation of sales. 29, comma something, comma, and then size is the sample size. You have where the sample size is. Enter. What did you get? What did you get? Nati, what did you get? Now, this is the story. We'll do this quickly. Now, upper and lower. Now, remember when you calculate the standard deviation, it's based on the mean, right? Right? Now, and we know that the standard deviation is 29, and we had set it at 95%. Now, it says, based on the mean, with 95% confidence, a significance level, we are sure that the confidence interval will range by 10. What it means is, the mean is 45 point something. For the upper bound, we have to say equals this number plus the mean. For the lower, it's going to be equals to the number, mean minus the number minus the mean. There we go. Now, please note, are you done? Can you see this though? Please just keep up first before you calculate. Now, it says we are 95% confident that our mean will range between these two based on the data. So for planning now, that's when it comes in. Fine, we know that the mean is 95, is 45 something. Now, for planning, you can always be sure that 95%, your sales for the next month, something like that, will be between these two, based on the calculations we have. Now, this is where your question comes in later on. Now, because now everything was based on 95%. Now, later on, when you do a hypothesis test, it falls out of this boundary. We now accept later on at 80%. It now violates this. Now, the results are inconsistent. That's what it means. Whenever you choose significance level, you have to stick it out the whole project, the whole analysis, because everything will be based on that. That's what it means. Are you with me? Now, when you do a t-test, for the test that the hypothesis that the next year's sales will be 60%, it's outside this range already. Now, it will be rejected because 95% covers this. Now, 60 is outside. Now, therefore, you will reject it. Now, people will force to accept it at a lower percent. That is the problem. Because now, it will no longer be valid for 95. They will force it to accept at 80. Because at 80, you can accept. Now, let's do a simple case. Let's do a confidence interval for 90%. You will see a different result. Quickly try and do an equals to confidence for 90%. When your alpha is 0.1, if you don't have the numbers, you can type them out directly. Equals to confidence. Alpha is 0.1, comma, standard deviation is 45, is 29 point something, comma, and your size is 34. Enter. It's a lower number. 8.40 something. Now the same applies. Now if you do the confidence interval, this interval, interval of the confidence interval has to be subtracted and added to the mean. So then you get the upper boundary and the lower boundary. That's what it means. Now, you can see already the number is lower. So there is a good chance of making a mistake. Are you with me? 10%. You are more likely to make 10% error now. Now the same applies when it's 40. Just try 44 just for explanation's sake. What is the confidence if you are using 40% chances of error? Nati, what is the confidence when it's 40%? Am I still okay? Zero point four, yeah, 4.3. Okay. Did you get 4.3? Size just 34.
34.
Yeah, 34.
Or enter.
I think where's your B4? B44. B44 is supposed to be the second one. Okay, let's do the second. Alpha is going to be 0.4 first. 0.4, comma, then you comma, no, yeah, then you go to that thing, B44, because this one says standard deviation, comma, 34. It says now science 34. Enter. That's what it means. Yes. The 4 points of this. This is a concept in research we need to drill into people. People want to accept things because they want to suit. Remember, most statistics, correlation we'll do later on, they are based on 95% confidence interval, the significance interval. Yes.
Is why with a lower confidence level, your range, if I can call it range,
Yes.
becomes small. Shouldn't it become big?
No, no, because now you are saying you are bound to make more mistakes. First of all, understand. This is the volatility is 29. And the mean is 45. Now, if you are going to say the next sales are going to be 46, there's a good chance you're making error. Are you with me? So the error increases as the number is close, as the number goes draws closer to the mean. As it expands, chances are you are covering the 29. You with me? Because it can swing anyhow. Everything is based on the mean, unfortunately. Yeah.
It's now very good you explain it step by step, but it needs practice, it seems.
Excuse me?
You need practicing these things.
True, yes, unfortunately. But you see, one thing I was trying to mainly do is because most people, even if they do have qualitative, they would somehow as well find a way to calculate mean, t-test, this and that, but still not understand and not do the correct things. Yeah, having a research that accepts things, it's not necessarily, you cooked, chances are you cooked because things are not as rosy. but unless it's statistically justified.
Can you put your program again for the next session? For next week and the week thereafter.
Oh, the program, it's okay. Okay, this one. Yes.
Next week, you plan something else different from this.
The stats.
Yeah.
Yes, it was.
Different from what we're doing now.
Yes, it will be different. Or you reckon we should continue with this?
I think this is important to do, but I don't know.
The rest of you, what do you think? Gents, Facebook, ladies, lady? What do you think? He's suggesting for next week, possibly, we come to the lab as well and continue with the stats. Okay, this and this and but this I think we can also capture on the monkey survey. This is not the big deal. This is not the big deal. This we will force you to do it anyhow. So I'll say this too. Questionnaire development. We just want to cover it in the program, because not everyone is analyzing. Not everyone, see. But we can also cover it here, if possible. Here, and then chances are, to develop a questionnaire, there are some few pointers that you really need to go through. Who are the respondents, the level of education, language, number of questions with relative to the sample size that you have anticipated, all those things.
I think that's important as well to do. But I see, according to the number of slides that you had, we actually only halfway now. I don't want us to rush through the rest because it's already 5 to 7.
Okay, I hear you. Okay.
I would like us to look through this properly, if it's possible.
It is possible, actually. But it makes sense, though. Anyway, I'm still with the rest of you. What do you think? I tried to make it short, but you concur. Ebeo? Next week? To at least, or let's safely say, we will use the same venue, and then for the first half of the session, or whichever comes first, either the questionnaire or the stats, whichever, but the other half, can you do the stats? So then we don't miss out on the other part. Okay? I'll pitch this to Prof. Berry, but I don't think it's going to be a problem, because at the end of the day, the idea is to try and educate as much as possible. Yes. We can still see this. So even if we work through these slides, they are here. It's not a matter of, yeah.
Can you just ask them, or maybe yourself or Naudi, just email us again just to confirm that?
Yes, that's fine. But let's pass it through Berry to get to Nat. Yeah. Yes. Yeah. It is late. Questions so far? So that then when you pause here, so far, so you understand. Yes. Questions so far? This is the issue that is big on stats. This is why we try and try and try and try. The best way to reduce both errors is to always have a bigger sample size. We are working with 34 units, or 34 data, sample size of 34. For us to improve the errors, we have to increase the sample size, because therefore then it accounts for most now. Or the idea is the sample size will try and draw to reality, or to be as close as the population size. That's why the sample size has to be increased. because the sample reflects the population. Always, this is the first step in stats. Don't get a sample, first start with the population. Only in the event you can't get a population, then get a bigger sample. If you can't get a bigger sample, get a smaller, biggish sample. But don't start with 10 or 34, because that's bad. Are you with me? Thank you. Have a good day. 7 o'clock. Questions, please. Questions, please. Oh, yeah, one of the questions we will ask you is with relation to the presentations of the workshop. The way I present and the way Prof. Berry presents, two different. So for me, what is good, what is bad? For her, what is good, what is bad? And ultimately, we still need to try and, we need to try and impart as much knowledge as possible. So please look out for that. That's part of the reflections of the workshop. There will be aspects on those things. Yeah.
We're still going to talk before I forget.
Yeah.
I will not be able to come.
Yeah, please.
This workshop, I'm still going to say the same thing I said to Prof. Robert. What is the possibility of introducing this from BTEC?
No, that's also one of the things we are looking at now. The reason we are also compiling this information is to try and structure it, thing is, you can't introduce something at BTEC if there's no structure. So let's formalize the structure and then now say, okay, that is one of the things, possibly started 2014. Because it also has to pass through not 2014, 2015 or 2014, somewhere there. Because next year it has to go through the process, Senate, the council, all those things for approval. It's a big issue. Ideally, people should not come to, they should not come to Mustard without some basics. Meaning these things, those are the fundamentals. Even the methodology, all those things. Thank you. Have a good evening.
Thank you very much. The same to you.
Thank you.